we will learn about another programming concept called arrays. Today we will learn another programming concept called arrays. So here, can you remember what is a variable? Can someone answer? What's a variable? We have used variables multiple times.
In a variable, we can store temporary data.
Yeah, that's very good. So variable is a okay. Very good. Variable is something where we can store data use while we are doing some programming, and we can when we want some data, we can call a variable and take those values inside the variable. Then so we can compare a variable to something like jar. So we can put anything into the jar and we can name it, and once we want something from the jar, we can take the jar and take the things inside the jar. Variable is something like that. So typically variable has a name and a value. So variable is something we can store our data temporarily, and then we can use them when we executing or running our program. And typically variable has a name and a value. In programming languages, typically there are some programming languages may not have this feature, but most of programming languages have variable types. So we can define the type and we can put the value. And multiple data according to the situation. For an example, let's assume you have to store marks of the class members of your class. So as if there is something like 40 students, you have to store 40 numerical values, and they may have in same type, and you can give a name likewise. So guys, in that kind of situations, we can use a concept called arrays. So if we compare a variable to a single jar, where it has a name and we can put something into it, then we can consider an array as a multiple jars in a row. So we can give a single name for the entire row, and we can name the independent jar with using a number. Typically, in the programming, we will call the name as array name, and the value or the numerical value we will use to identify each of the jar, or in the programming, each of the component will be identified as array index. Did you all get it? Guys?
Yes, sir.
Okay. So we can implement a simple array in our make code environment as well. So let's check how we can do it. So here guys, there is a separate block which is related to arrays. Simply what we can do is we can create an array. So what you can do is you can drag this block and drop it there. Typically, there are two types of arrays in this program, which is we can store numerical values, so we can have a text list likewise. So to name, so we can name the array with a certain name, let's say S1. Okay, then we can store the values. So I will store a couple of values here, which is 0, 11, 5, 10. So those are my values. Now guys, by calling the array name and the index, we can access certain values. For example, I'll try to access some value and show it to you. Input. Let's say one button A pressed. I want to show number, and the number is I want to so number is something you are familiar, and to get a certain value, what I can do is I can go to this array tab, and here you can see something like get value at, and I want to select my array which I have created in on start, and I want to show the 0th value, and I will change the 0 value to 12. And let's try whether it is working. If I press A, 12 is appeared. So here you have to understand that our array indexes are starting from 0. So it will be a common concept in programming languages. In most of programming languages, sorry, in almost all programming languages, array indexes are start from 0. So if I go to my presentation here, you can see I have start the values from 0. Then if I want to have 0, 1, and 2 second value, let's say what we can see, and it will be 5. So 12 is 0, 11 is 1, 5 is the second value. Did you all get it? Are you all good with that? Guys, can you hear me?
Yes, sir.
Yes, sir, we can.
Okay. Then I'll show you another thing with arrays. So guys, in some programming languages, we have to go through the entire length of the array. So in that kind of situation, it's a common use or common functions will be there to get the length of the array. For example, let me show you in our array tab, there is a block which is called length of array. So I can drag it here, and if I select my array name, and then when I press it, it shows 4. That means we have 4 elements in our array. So I repeat it, we have 4 elements in our array, which is 12, 11, 5, 10. And so that our length is 4, but our indexes is starting from 0. 0 is assigned for 12, 1 is assigned for 11, 2 is assigned for 5, and 10 is the third element, and third, which means third index. Then we will try some activity with okay. Now what we can do is we will create some program where it can store some names of foods. So when we want to have some food, or if we can't decide which food, microbit device, and then it will suggest something for us. So that will be a simple application. I repeat. So what we are going to do is we will store some names of food in our microbit device using an array. And what I'm going to do is if I shake my microbit device, it will appear random food name. So let's say we can't decide what we'll have for our breakfast. So what we can do is we can get our microbit device and we can shake it. Then it will suggest something. So I will create something like that. So what I'm going to do is I'll create a new array which is text list, and instead of text list I will create a new variable and I will name it as let's say food. Okay, then I will add some names: rice, sandwich, noodles, maybe toast, okay. I have created an array with some name of foods. Then can someone say what is the length of the array? What will be the length of the array?
Five.
Yes, it has its length as 5. Then what is the index of noodles? What will be the index of noodles?
2.
Yes, 0, 1, 2. It will be 2. So let's assume first when I press A, it should go in, it should appear the list, the entire list. So that what I can do is I can go to my loops, and here there's a special loops, which means for index from 0 to 4. And what I can do is I can drag it here, and then if I execute this, what happens is the index is something like variable, and it will want to do is I want to go through my entire array, so that I should assign my length, the length of the array is so to show you something. First, I will use the index and use show number block. Then, if I run it, 0, 1, 2, 3, 4. Then, what I can do is I can go to array and length of the array, and I'll select food. Then it will go to, or it will assign I'll use short string here and array and get value at my index. Okay, then we can run it. Should be some issue. Okay. Good. Okay, the list is appearing. Noodles. Toast. And pancake. And there is something unknown. That happened because if we take the array length 5 here, it will go from index 0, 0, 1, 2, 3, 4, 5. But here we don't have any fifth element because if rice is 0, then sandwich is 1, then noodles is 2, 3, and 4, and there's no fifth one. So that what I can do is I can go to my maths operation and take this and I can subtract 1. Now when the length is increased, our index go from the length minus 1. Now it should be okay. Then if I shake my shake my microbit, it should give me some random food. So that it's very simple, and we have already did similar things. So I can go to the input on shake, show string, and I want to have some random food. So I will go to my array, and again I want to get a value and go to my maths operation, pick random, and it should be 0 to 4. Then let's shake it. Okay, here I have to select food. Then run it again. If I shake it, okay, there will be some random food. Okay, then any questions? Guys, any questions? If not, can you create something for me with the same concept? I will give you some couple of minutes. You can try arrays with your ID. And then you can show it to me. Okay? Did you all get got the concept? Guys?
Yes, sir.
Okay. So what you can do is you can create something similar and show it to me. Then we will go to some electronic parts. if you have any question, feel free to ask. I will explain it again. Or if you want to explain this or whole concept again, you can ask. There's no issue with that.
Sir,
Yes.
what if we download it?
Download what? Tinkercad?
This program?
Yeah, if you have any microbit device, you can download. You mean about the button in the corner?
Yeah.
Yeah, it's for it's to download the code. So if you have a physical device, what you can do is you can connect it to you connect it to your computer and you can download. If you can see my screen, there's a way to connect it. There's a small jack on your microbit device. So what you can do is you can plug it to your computer and then you can download it. So you can run your program in an actual microbit device. Okay, did you get it?
Yes, sir. Sir, the Tinkercad එක කරනවද?
Physically කරමු කියලාද කියන්නේ? Tinkercad එකද වහන්නේ? Yeah, I didn't get your question.
Oh, sir.
Yeah, we will do Tinkercad as a. Once we finish with arrays, we will go straight to Tinkercad and we will do some activity for the Tinkercad.
Yes, sir.
Yeah, we will check it later. Okay, when we
Okay,
start the
sir.
Tinkercad, we can solve this.
Sir? Sir,
Yes.
I want to see the JavaScript of this.
Sorry, I didn't hear.
I want to see
Yes,
the JavaScript.
actually, yeah, I'll show you. So once you go to JavaScript instead of this block, you can use JavaScript as well. But when I checking the codes, actually you may have two different concepts when you are using. Typically, we program the microcontroller devices using programming languages like C. So there will be a little deviation when using JavaScript and using the actual microcontroller devices. But it's pretty much good if you can understand those things. Typically, what happen here is we can use some actually it's like yeah, if I explain it to you, I should explain some object-oriented concept as that. No, these are called functions. So what we can do is we can get some object and dot operator is to access their own functions, and then there will be some functions. So you may have to have some reference document to learn those stuff. But it's okay if you can use JavaScript as well.
Okay, sir.
Sir, can I share the screen?
Yes, you can. Can you show the course as well? So here little issue I can see. You have created the variable called food for the array. Then when you're using the show string, you have a selected food when you get in the values. No, not that. The next one. The list one. Yeah, you can select food on shake as well. Now, in the on-check block, even in the on-check block, you have to select food instead of list. Okay, then you can run it. Okay, nice. Okay, very good.
Sir, can I show?
Anyone else? Yeah, sure.
Sir, I can't screen share. I will show in my camera.
Okay, fine. Okay, good.
Sir, may I show it?
Yeah, you can. Nice. Does anybody have any physical microbit device, actual microbit device with you? Can you show me the code? There, I think there's an error with your program. Clothing, color purification. Yeah, you have the same issue. So in button A, if you yes, in the button A as well, in short string block, you have to select the proper array. No, still it isn't selected. Okay. Now you can try. Nice. Very good. And you have selected something to select the color of the cloth, isn't it? Yes, very good. Anyone else? So guys, if you want, you can try the JavaScript as well. I think you are matured enough to use JavaScript. So here what happening is if you want to access some input, you can use input, type input. And once you have a dot symbol, there will be some functions you can use as use the input. So here you can see that on gesture, on pin pressed, where we can access our pins. Likewise, on button pressed, likewise, the functions are available there. And then you have to mention certain properties actually that might be something confused, something complex for you. but if you are familiar with some programming, you can try it as well. Then you have to select which button you have to press, and then you have to create a function. The inside of the block is contained, so that we have created this function, and that's how the things happening. But since we are taught to give a brief introduction on programming, I think it's okay if we stick into the blocks. But if we are okay with JavaScript, it's better if you can try program using Java. Guys, or any questions?
No, sir.
No, sir.
Or shall we go to Tinkercad?
So you should, yeah, we should go to the cat. No.
Okay. Okay, we will. Then this is the Tinkercad program. Let me log out and show. Guys, give me please give me a couple of minutes. I have a little network issue, so I'll fix it and let you show. Okay, can you all see my screen?
Yes, sir.
Yes, sir.
Guys,
Yes, sir.
okay.
Yes, sir.
Then once you go to Tinkercad, what you can do is you can use join now and join now, and you can create a personal account. And the most easy thing you can do is you can sign in with your Google account. So I hope you have created a Google account, and you can click it and log in. Sorry guys, my network connection is too weak, so let's be patient. Then you will get this kind of dashboard. Okay. Next, what you can do is once you are having this dashboard, you can click this
Excuse me,
circuits button here. Next is create a second. Yes, any issues?
සර් මං ක්‍රියේට් account කියන එක ක්ලික් කරා ඒත් මේ වෙන්නේ නැහැ නේ සර්.
Network issue එකක් නැද්ද ඔයාලට?
පොඩ්ඩක් ඉන්න සර් බලන්න.
Okay. So can you otherwise you can share your screen and let's check what has happened. So you can click create account button. Okay, you can click it.
සර් ක්ලික් කරාට ඒක මේ කිසිම දෙයක් වෙන්නේ නැහැ සර්.
Can you refresh the page and try it again?
ඕකේ සර්.
Sir, we can't screen.
So okay, any issues? Anyone else having any issues? Did you all can log this dashboard? පුළුවන් වුණාද ඔක්කොටම log වෙන්න අනිත් අයට? So if you have logging, can you raise your hand? Okay. Others? Well, the 34 students in the session. So what about others? So I'll give 5 minutes. If you have any issue with your login, please let me know.
Excuse me, sir.
Yes, any issues?
For some reason, my screen is different than yours.
So can you share?
Okay, sir.
Let's check what has happened. Okay, what has happened is that you haven't selected circuit and you may select another tool. So what you can do is can you please click the logo over there in the left corner?
Yes.
Yes.
Sir, can you tell me from the beginning?
Then select circuits instead of 3D design in the tab in the right corner. Select circuits and now you can create new circuit.
Okay, sir.
Okay, right. Others? Others, what has happened to you? Did you log into the correct dashboard or correct environment? Guys?
Yes, sir.
So raise your hand if you have successfully logged into this environment, then we can continue. Otherwise, there's no point of continuing without practicing the thing. So I will give you a couple of minutes. I hope you all will be able to log in. Okay, half of you have done the thing. Any issues? Or shall I continue?
Sir, what do you have to do?
First, you can raise your hand when you are done logging the screen, the environment. That's all you have to do. Then we can continue with some electronics.
Excuse me, sir.
Yes.
Sir, we met
Sorry, මට ඇහුන්නේ. ඉෂුවක් මොකක් හරි? Okay, since time is passing, I will continue. So guys, so far we did some programming with our microbit device. But guys, when you come into microcontroller programming or using microbit devices, it's not enough to use the sensors within the microbit device. What we can do is we can use some external sensors from outside. That may be some LEDs, some sensors, or some extensions. Likewise, we can use some other inputs from the outside as well. So if we use those kind of setups, you may have to have a good understanding about the electronics as well, so that you can design your own design. So I will give a very little brief introduction on using certain components and interfacing external components to your microbit device and how to control them using your microbit device. So guys, first we will learn some basic electronics. So guys, I hope you all have used or used LEDs and you have light up those LEDs, aren't you? Have you any prior experience with using some small circuits to light up some LEDs? Guys? Have you seen LEDs? Can you all hear me?
Yes.
Yes, sir. I have seen
Okay.
LEDs.
Yes. Did you use LEDs in your projects?
Yes, sir.
Okay, you may have used those LEDs. So here first we will try to blink some LED with microbit device. So it's better if we can use some physical device, but unfortunately this, so far we did the course online. So we will use the simulation environment to do so. So guys, in when we are lighting up an LED, what we are going to do is we will connect a battery with a certain voltage, and in the middle, typically we will use a resistor here. I will tell you what's a resistor, and we will connect the LED and we will complete the circuit. And when we connecting an LED, there is a positive and negative terminal with it. Typically, we call them anode and cathode, but it's not necessary. You can call them positive and negative terminals. So we have to connect the positive side or positive pin of the LED to the positive edge of the battery or the power supply, and negative pin to the negative edge of the battery. That's how we can light up an LED. So guys, let me show you how the things happen inside. So we have to understand the terms which we are using as voltage, current, and resistance. So guys, assume a tower which can distribute water. To have a flow of water, we have to have a tank in a higher position. Then only that water will flow through the pipes. So guys, if you consider the water as the current, the height of the tank will act as the voltage. So voltage give a force or the potential to flow the current, which is similar as when we increase the height of the tank, the speed of the or the amount of the water flowing will be changed. That's how the voltage works. Then guys, resistance is something like a obstacle to flow the water. So if we have a tap or something, a valve or something in the middle of the pipeline, what we can do is we can rotate them, or we can turn on them, and then the flow will be reduced. The resistor act similarly, and what it can do is it can reduce the flow or restrict the flow. So that's a simple term, but it's not necessary to completely understand it, but it's better if you can understand it. Typically, I know the children in your age always do some experiment with the batteries and LEDs. So even without the terminology, you can use the circuit. First of all, to have a good understanding, shall we try to create some little circuit with the ID with Tinkercad environment? So we will light up some LEDs. So I will show you how to do it. Okay, I will share my screen. First, we will light up some LEDs. So first, you have to have the components with you. And if you select basic here, I hope you can see, you can have the basic components, and I will light up an LED. So what I can do is I can drag the LED and drop it here. Then I want some batteries. I will use this coin cell as my power supply. Then I have to have a resistor. So guys, basically we use the resistor for the protection of an LED. So when you study the electronics further, you may know how it acts. But in this stage, I will not try to explain it further. We have to use the LED to as a protection, and typically the LEDs have a color coding. Sorry, the resistors have a color coding. So if you see the resistor, you can see there is the color coding with here. So it will be brown, black, and red. If I change the value of the resistor, which is the resistance, let's say 220 ohm, it has changed its color coding. So I will stick with 100 ohm resistor, and it has changed its color. Then I can simply connect the circuit. And here I have to say how to select the positive and negative, which I forgot to tell it to you. So if you can see the LED, the longest pin from the two pins is the positive edge. The short one is the negative one. So if you have a physical LED, you can see that there's a long pin there, and it's the positive edge. Then if I go to my simulation environment, once you create the circuit, what you can do is you can select the run simulation button here. And now my LED has changed its color and it has light up. So can you please try it and show it to me? The basic circuit.
I have done, sir.
Okay. You can share screen. Nice. What about others?
Sir, I have also.
Nice. Good. Others? I'll give you 5 minutes for others as well. So they can try it as well. Okay, nice. Anyone else? Okay, good. Or if you have any issue, you can ask. Any issues?
Excuse me, sir.
Yes.
Sir, man join වුණා sir මේ මට ඕක ඇතුළට join වෙන්න බෑනේ sir.
වල ස්ක්‍රීන් එක ෂෙයා කරන්න පුළුවන්ද?
හා
අපි
sir.
බලමු මොකද වෙන්නේ. හරි, okay. Then ඔයා ඔතන circuits කියලා තියෙනවා නේද? අනේ ක්ලික් කරන්න. No, what you have to do is you have to go create a personal account. I think you have created something like student account or something. So first of all, you can log out, then you can select create an account and you have to create a personal account. Okay. ඔයා මම හිතන්නේ teacher account එකක් හරි student account එකක් හරි හදන්න නැත්තේ. ඔයා account එක හදද්දිම ඔයාට personal account එකක් හදන්න කියලා. එතන personal account එකක් තෝරන්න. Okay? Did you get
Yes.
it?
Oh, yes.
Sir, can you share the screen?
Yeah, I will share it. Okay, this is the screen. And you can have the connections like this.
Sir,
Yes.
how did you connect the wires?
So if to connect the wires, what you can do is first I will delete this one. Just go to the point you want to. Now you can click it and then you can drag your mouse.
Okay, sir.
And you can connect it again. Any issues?
No, sir.
Okay. The students who have connected the setup, so you can use this slide switch. And what I want to do is, I want to have a switch to turn on my LED and off my LED. Can you? So you can try with a switch.
Okay, sir.
Excuse me, sir. How did you add that resistor or something?
Here, if you go to the basic components, there's a resistor there. Can you see it?
Yes, sir.
Can you see my screen?
Yeah. Okay, sir. I can see. Thank you.
Yeah, you can drag it there and you have to change the resistance. Typically, there will be 1 kilo ohm. The kilo ohm is the unit to measure the resistance. Okay, guys? And when we increase the resistor value, it will eliminate the current flow so that there will be a voltage drop over there. That means your LED will be either will not turned on or maybe low with its brightness. So that what you have to do is you can change the resistance. So for this circuit, I have used 100 and ohms. So my resistor value is 100 ohm. Did you all get it?
Yes, sir. Thank you.
Okay. Then you can connect the switch. And if you have connected the switch, you can share your screen and show it to me.
Finish, sir.
Did you?
Yes, sir.
Can you show it to us? Okay. Nice. Anyone else? Okay, good. Others also can try with the task. I'll share the screen if you want.
So I created one. Sir, can you see the screen? Excuse me, sir. Sir, can you see my screen?
Yes, I can see it. Okay, good. Nice. Then for those who didn't connect the switch, I will show you how we can do it. So I will put my switch there and I will connect one end of my wire to the middle pin for the common one, and I will connect my terminal 1 to my LED. And then if I start the simulation, I can switch on my LED and switch off my LED. Then guys, when we think of blinking an LED, what happened there is it is a process where we continuously turn on and off my LED. So that means we can continuously supply power and will stop supplying power continuously. Did you get it? So if I want to blink my LED, what I can do is I can switch on and off my LED continuously. So then I want before creating something with microbit, I want to explain you the concept of analog and digital. Anyone knows what is analog and digital signals? Can someone explain to me? Guys, at least an example.
Sorry, sir.
Can someone explain me what's digital and analog signals or digital and analog devices? Or any
Analog
example of analog
multimeter,
and...
digital multimeter.
Yes, very good. Someone else? about any explanation of signals? Yeah, I will show it to you. So guys, typically in electronics, we will use either analog signals or digital signals. In analog signals, you let's say 0 volt to 5 volts. In our signals, we can have any value between 0 to 5. That means from the range which we are using, we can have any value. But in digital signals, we will have either 0 or 1. So in electronics, the 1 may be representing by 5 volts, 0 may represent by 0 volts. That will depend on the context, and you will deeply learn about this concept if you learn electronic engineering in your future. So typically, it's like in analog signals, we will use continuous values, which can spread in the entire range. But in digital signal, we will have either 0 or 1. So that's how the analog and digital signal works. So when you're using analog clocks, they both here it represents some mechanical devices which we can have any value with its operational range. But in digital signals, almost all the digital systems are electronic, and they are using ones and zeros to represent the certain data. So that's how analog and digital signal works. And in electronics, for digital signals, you can consider it as a simple switch. Don't bother about the details in the right corner. Simply consider the digital signal as a switch. So if you want to represent 0, we can represent it by switching off the system. So if we want to represent 1, we can turn it on. Did you all get it? Guys, should I explain again?
Yes, sir. Can you explain it again?
Okay. So guys, we have two different systems in electronics, which is analog signals and digital signals. In analog signals, we can represent any value with its operational range. That means, let's assume you are using a system which has a ground and 10 volts. So your system or your signals may have any value between 0 and 10. So your signal may be 0.1, or your signal may be 6 volt, or let's assume a voltage signal. Your signal may be having 2 volts, 3 volts. Likewise, it may get any value between 0 to 10 if you are operating a 0 to 10 volt range. Okay, did you get it? If we are using a digital system, it will represent either 0 or 1, or that means 2 states. So if you want to have a 0, simply what you can do is you can represent it with 0 volts. And if you want to represent 1, you can go to the highest voltage. Let's take a system with 0 to 5 volts. So 1 will be represented by 5 volts. So if we talk about the digital signals, you can assume a digital system, the digital signal using a switch. So once your signal switch is turned off, it will pass no current, so there will be 0 volts. And if we turn it on, it will go to its voltage, and that will appear as a 1. So if I go to my circuit, I can use the digital signal to turn on and off my LED, because if I turn it on here, it will be 0. In this point, it will be 0, and we have rounded the LED in this terminal, and now here it will be 0. If I turn it on, now the voltage will pass through the resistor and go to this path, and here the voltage will be 3 volts. If I make it off, now it's 0. If I make it on, it will be in its highest position. Did you all get it? Did you all have this concept? Guys, is it okay? Any questions?
No, sir.
Okay. Then we will try to turn it on and off using a microbit device. So you can scroll down, and there is a microbit device you can using. Even you can use it in a Tinkercad, and once you drag it there, there's a small button called code, and you can use the code blocks, which is pretty much similar to Tinkercad make code environment. You can drag and drop those components and program the microbit. Now, at the very beginning of the microbit session, I introduced you that there are several pins in the microbit device, which is 0, 1, 2, and there's a 3-volt pin and ground pin. So the 3-volt pin, or actually it's a 3.3 volt pin. So it will emit 3.3 volts when we turn the device on, and this pin always grounded, and we can use this P0, P1, P2 as our purpose, and we can use it as either inputs or GPI, which means general purpose input and output pins. So we can use it for general activities. Now let's check how we can connect an LED to the microbit device. So what I can do is, first I will make my ground pin connected to the ground of my microbit device. Okay. Then I will connect the resistor, and the next terminal I will connect it to my pin 0. You can connect it either to pin 0, pin 1, or pin 2. There's no issue with that. And if I run it, nothing will happen because we have to code it. Then if you click the code button, you can code it. What I want to do is I want to turn my LED on. So as I mentioned, I want to have a digital output and make the pin high. I mean, it will emit the voltage, or it will have the voltage. Actually, it's not emitting, it is having the voltage. So that I'll go to my outputs, and here there's a block called digital write pin. So actually, write means to generate it. So I will use the digital write pin. let's put it into on start. And I have to select which pin which pin I should use. So here it is 0. So here I will select 0 and I want to make it high. Then if I run it, my LED is turned on. Can you see it?
Yes, sir.
Okay. Then let's put it into my forever loop as well. Even in forever loops, it is turned on, and if I make it low, then what happens is my LED is turned off. Can you see? If I make it high and start the simulation, it is turned on, and if I make it low and if I run the simulation, it has turned off. So if let's say if I want to change the pin, I'll assign a separate pin, and then I should change my pin and run. It's not turned on. If I make it high and start the simulation, it has turned on. So can you all try it? Then we will make it blink. Can you try this simple circuit? I'll give you a couple of minutes. You can try it. So if you have any issue, you can ask.
Sir, I have made it.
Okay, you can share it.
Sir, I am showing.
Okay, nice. Can you make it turn on? Okay, good.
Thank you.
So I have made a blinking LED.
Okay, you can show it. Nice, very good.
So I can show. So can you see?
Okay, you can show it. So far I can't see.
So can you see?
Yeah. Now I can see. For those who finished the circuit, can you please make it blinking by yourself? Can you please try it?
Sir, can you see?
Yeah. Okay.
Sir, I have made it like Dinky.
Okay, you can show it.
I am showing, sir.
Okay. Nice. Very good.
Thank you.
What about others?
Sir, I also did a microbit. Can I show it, sir?
Yeah. Sure. Okay, you have make it blink. So can you please blink it faster? Make the speed increased. Good. Very good. Others?
Sir, I make it like fast.
Okay, you can show it. Nice, very good. Excellent. Let's give 2-3 minutes to others to complete the task. Otherwise, I will explain how you can make it blink.
Sir, I
Yes,
made
go-
blinking
oh,
slow,
okay.
fast.
Okay, you can show it. Nice, very good. Anyone else? Anyone else?
Please wait a second.
Okay.
So it didn't work.
So, okay, then I will show you how we can make it. So let's go here. And simply to make it blink, what I should do is I should turn it on and off again. So you know how to make it turn it on and off. Let's do that. So once something in our forever loop, it will run again. So if I do turn it on and off inside the forever loop, together, to make it visible, we should have some wait as well. So we can delay the process for a certain number. So what you can do is we can go to your controls. So yes, there is a wait block there. So first I should draw digital write pin 1, which make the LED turn on. Then I will wait a couple of seconds. Actually, I have make it 1 second. Then I can use the same block and I can make it low and I will wait again. So if I do the process again and again, it will appear as my LED is blinking. So I will run it for you. And you can see my LED is blinking. So if I want to make it much faster, what I can do is I can reduce the delay time or the time which we are waiting. So it's very simple to do. What we can do is we can go here and instead of seconds, I can select milliseconds. So 1000 milliseconds is equal to 1 second, and I will change my value to 500. So it will be half of second, 500 milliseconds, and I can run it. Now it is much faster. Let's say 100 milliseconds, and now it is even faster. So that's how we can make the LED blink using the GPIO pins. Okay. So the students who didn't try the blinking, can you please try it? And if you have any issue, you can ask.
So my one doesn't work.
Sorry, I didn't hear you.
My one doesn't blink.
So can you share your screen? Let's check. Okay, you have connect your ground correctly and you have wired it. And so can you please tell me for the which pin you have connect your terminal or the terminal from the resistor to which pin?
0.
Okay, you have connected to 0 pin. Okay, that means P0. Then can you please go to your code? Then in digital write pin, you have to select pin 0. Now I can see you have select pin 1. So instead of pin 1, you have to select pin 0. For the next one also, you have to select pin 0. Now can you please run it? Isn't it working?
Yes, sir, it works.
Yes, it works.
Thank you.
Okay. Others?
So shall I share screen?
Yes, you can share screen.
So am I correct?
Yes. Very good.
Thank you, sir.
So if you have any question, you can ask. There's no issue with that. You can clarify anything you want. Is there anyone to show your work? Guys, did you all do the task or do you have any questions, any issues?
No, sir.
Okay, so I will show you another artwork as well. Let's say we have to play some sounds. So let's check what we have with us. Let's check whether we have something like buzzer. Yeah, this will work. So you can try other sensors, devices with you as well. So let's check how we can connect a buzzer with our program. Okay. So any device which has a ground should be connected to the ground. There should, if there is no any extraordinary situation, most of our ground are connected together as a reference point, reference voltage. So every ground terminal should be grounded, and I have connect my positive input to the pin 2. Then to play the sound or play a tone, we can play a tone using a buzzer. You can go to code
Excuse me, sir.
and in our output. Yes. Any
Sir, I
issues?
made two LEDs blink at the same time.
Okay, you can show it to us. Okay, you can
Can
run
you
it.
see that?
Yes. Okay, nice, very good.
Thank you, sir.
Okay, we were talking about using a buzzer. So here you can see there's a analog set switch pin. So we have to use this pin, this block to work with buzzer, and we have to select the pin which we have connected to the buzzer. So here it will be P2. So I will select P2, and to play a tone using a buzzer, you can use, let's check, analog pitch, and we have to set the pitch. I'll use 400, 500, and for how many milliseconds to make it play. I'll say 100 milliseconds, so it will generate a sound with a pitch of 500 for 100 milliseconds. And let's put a wait as well, and we can run it. Can you hear it?
Yes, sir.
Okay, likewise, you can connect the buzzer as well. Then you can try, there are some other sensors. In the next year, I will show you how we can use some PIR sensors and some other outputs, analog outputs to take input to our microbit devices. So I'll give you the time to show what you have created. If you have created something further or some creative thing, you can show it now. Or if you have any question, we can use our last 5 minutes to clarify them. Any questions?
No questions, sir.
Sir, can you show
Okay.
the code?
Okay, I will show you. So you can try it by yourself. Because we have learned so many things using my code environment with Scratch and with Tinkercad, you can create some creative things, games, or anything you want with these devices, and you can share it with us in the next session. Okay, if you have created some nice things, you can share it with us. Did someone connect buzzer to your microbit?
Yes, sir.
Yes. Did you do it successfully? Okay, can
Yes,
you
sir.
show it?
Can you see, sir?
Yes. Apparently, I can't hear it, but I can see that your buzzer is ringing. So it's fine.
So I have done it successfully.
Others?
I
Yeah,
have
you
done
can
it
show it us. Yes, you can share soon. Okay, nice.
So did you hear it? So did you hear it?
Sir? 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 Sir?
And if you want to change your color of the wiring, you can do it in here. You can give separate colors for your wirings. Okay, that's how the by yourself. And if you have any question, you can ask. Otherwise, we can wind up the session.
Sir, can I show my one?
Yeah, sure. You can share.
Sir, can you see now?
Yes.
Sir, I shared the sound too.
Okay. Okay, nice. Very good. Okay, good.
Sir, can I show my one now?
Yes. Okay, good. Anyone else or any questions? So if you are good with what we have learned today, oh yeah, you can show it.
Sir, can you see?
Yes, I can see. Can you run it? Can you please run it? I can. I can't see whether it's done in on off. Okay, seems you have an issue with you.
Sir, now
Okay. Yes, I can see. Yeah, it's working. Can you please show your code? Yeah. So in your wiring, it seems that you have connected your buzzer to the 3 volts. But when you are using it, it should be connected to some GPIO pins, which is pin 1 and pin 0, 1 or 2. And then you have to use the set pitch pin to make it working. So let me show you again. So I have ground my pin here, and I have connected my positive terminal to a GPIO pin. Then in my code, I have set my analog set pitch pin to pin 2, and then I have given block to make the sound playing. Okay, did you get it? Anyone else? Okay, guys. Then we will wind up this session, and thank you for your participation, and goodbye, guys. So in next session, we will learn some further electronics with microbit, and we will use some PIR and motion sensors in our next session. So you can try it if you have any available time for that. Then goodbye, guys. We will wind up the session.